All right. Apologies about that, everybody. Still, again, trying to make things right, although I can't say it's going to be working that well. All right. All right. Thanks for sticking around with me, though. I appreciate that. Okay, but we need to do some problems here, so let's go ahead and do some problems. Okay. So let's go ahead and take a look at some ratios and proportions, okay? And we'll just go ahead and put it together. Okay, so let's look at this first one here, which will be number 3. If 28 tapered pins can be machined from a steel rod 12 feet long, how many tapered pins can be made from a steel rod 9 feet long? Okay, so let's go ahead and try that. All right, so what we want to do here is we want to go ahead and set up our ratio. So let's do that. Ooh, all right. So 28 tapered pins and 12 feet long. So what we could do is we could put 28 pins on the top, and 28 pins go with 12 feet long here. Okay. Then this is going to specifically equal 28 pins over 12 feet, and then on the top here we can have, again, we have X amount of pins that we need to find over 9 feet, which is the rod that we're given here in question. Okay, then we'll go ahead and cross multiply here. All right. So we're going to have 12 times X equals 28 times 9. All right. So here we got, all right, so we got 28 times 9. What's that going to be? What is 28 times 9? 252. All right, good. 252. Is the, really quick, everybody, is the stream coming in a bit better? Is the stream coming in a bit better? Yeah, okay. Okay, for now. Yeah, I know, for now. There's always the for now part, but I will, at least that's working a bit better. So, all right, that's fair. For now. Okay. So let's go ahead and divide by, what are we going to do? What are we going to do next, actually? What should we do next if we're going to solve for x? Divide by 12 times 12 times 252? Not quite. Divide by 12. That's correct. So one of the things that we're going to learn in chapter 6, okay, and I want you to kind of put this in your back pocket here, because this is going to be something I'm going to stress on here very greatly once we get to chapter 6, is that in algebra, all right, in algebra, everything in algebra revolves around one word. Okay, is if you're going to understand how algebra works, everything revolves around always one word, and that word is always balance. Okay, so again, everything is always a balance in algebra. Meaning to say, if I divide by 12 here, then I have to divide by 12 right here as well. All right. So what do I get here in this instance? What's 252 divided by 12? 21. Okay, that's correct. So we get 21 pins here. So what I do on one side is what I have to do on the other side. Essentially, if I want to get x by itself, I do the opposite, opposite of multiply, which is divide. So I divide by 12. But then if I divide by 12 on one side to get rid of it, like say if I x it out, then I have 252 divided by 12, and then I have x is equal to 21. And that's how I end up with that final answer. So everything that we're going to be doing here is always going to revolve around this type of concept here when it comes to finding what a variable is going to be. Okay, so that's going to be our goal there for these problems. All right, so that's why, yeah, that's what I want to teach you here is like, hey, how do we look at this more objectively? Well, I'm looking at it from a balancing perspective. Okay, let's take a look at another one because, again, context matters, so we got to be a little careful. All right, so let's look at number 12. Yes, number 12. All right, so number 12 says a machinist can produce 12 parts in 40 minutes. How many parts can the machinist produce in 4 hours? Okay, so how do we set this up here? How do we set up this particular proportion? What should we do? What do you think? All right, that's right. Okay, totally agree with that, right? Because we want to set that at 240 minutes. That's correct. Okay, so the context here means a lot, right? We have, again, just labeling our sides here. We have 12 parts, and we have 40 minutes. All right, and that's going to equal X amount of parts, and correctly pointed out here as 240 minutes to reflect the 4 hours. That's correct. All right. So we'll cross multiply here again. So we'll have 40x equals 12 times 240. All right. And what do we get here? What's 12 times 240? 2880. All right. All right. And we're just going to divide by 40 here. And what do we get for x here? 72. Perfect. So 72 parts. Sounds bueno. All right. Any questions about that? Again, context can change, so you just have to be a little bit extra careful there. Any questions at all before we move forward? Okay, you got your answer. I'm guessing you just multiplied by 6 on the numerator and denominator there, Jamie? Jasmine, sorry. Yeah. So Albeit, while that's a good way of doing it for this particular problem, you may not have such a clear number to multiply on the top and the bottom there, on the numerator and denominator. For example, you could have a very strange ratio which may be requiring you to multiply by 2/3, and guessing and checking could be fairly difficult. This one's a more straightforward problem. I don't disagree with that. The issue that I have with is that you could end up having ratios that have weird numbers that you won't be able to do necessarily in your head. So that's why we do the cross multiplication, so we don't have to guess. So the last thing that we want to do in math is really guess. So the easy problems like these, yeah, I'm not going to disagree. Totally agree with your method, 100%. But then when it gets to like stranger numbers and stranger ratios and proportions, yeah, then it gets to be a big mess. So that's why I try and do it, the easiest way possible, but again, without the guessing and checking part. All right, let's take a good look here at another problem. All right. Okay. Let's look at number 30. Yep. I think it's the next page. Yep. Okay. All right. Now, if you want to know where this actually applies to, where ratios and proportions can be very important here, number 30 is a very classic example of that. So a business owner is currently renting her shop space for $94.50 per month. Her lease agreement states that her rent will be adjusted each July according to the CPI. Specifically, excuse me. Specifically, the ratio of this June's CPI to the previous June's CPI will be multiplied by the current monthly rent to determine the new monthly rent. If this June's CPI is 241.038 and last June's CPI was 238.638, will her new monthly rent be beginning in July? Round the nearest dollar. All right. So first and foremost here, let's talk about what CPI means. All right. So CPI means Consumer Price Index. Okay. So that's essentially what CPI means, Consumer Price Index. So now, why is the Consumer Price Index important to you? Well, because the Consumer Price Index basically reflects the level of inflation between prices at every single, well, according to government statistics, again, every month they figure Consumer Price Index every month, and then you can see how much inflation has gone up by from year to year or month to month. Okay, so for example here, if it's tougher economic times, then of course the CPI goes down. So in an economy like ours, that doesn't bode very well. But you can also use the CPI to determine, how much something is worth, like way back when, or vice versa. So for example, people say, well, how much is $1 million in 1910 compared to today? Okay, because they're not the same because of inflation. Well, you can use the CPI to determine that. And you could say, okay, well, in 1910, $1 million was worth this much. Well, now multiply it by a multiplicative factor of whatever. And now $1 million in 1910 is worth, say, just as a quick example, $200 million today. Okay, well, whatever. All right, so just throwing stuff out there. All right, so you can imagine that, yeah, when you want to make those comparisons between a price of, say, last year to this year, and you want to include inflation in that, well, the CPI is the way to go. The CPI, as a government statistic, is like 60,000 goods and services, all kind of lumped into one. And then you have and then essentially you have a thing in there that basically gives you a number, and this is okay. Hey, how much, what kind of index or inflation it kind of goes by. So that's what each of these kind of reflect here. 241 reflects 2.41 times the value of a dollar. Say they basically took a value of a dollar. They say a dollar is worth a dollar between 1980 and 1984. That's where they kind of took the, 100 is equal to $1. 241 would be 2.41 times that dollar, so something to that effect. In any case, how do we go ahead and solve for this? Well, she currently has $94.50 per month in rent. So all we're going to do here is do this very quickly. I don't want to do that one. So we have $94.50. All right, that's how much she owes in rent here. And then what we're going to have below is the CPI from last year, which was given to us as 238.638. All right, that's from last year. And then we have the CPI from this year. All right, so we don't know the rent here. It's X amount of dollars. But the CPI for this year is 241.038. All right, go ahead and cross multiply, and we're going to go ahead and solve for X. So we're going to have 238.638 X equals 94.50 times 241.038. Okay. All right. Anybody tell me what we get here on the right side? 94.50 times 241.038. What's that going to equal? All right. So a pretty large number there. I don't think anybody would question that. So 2277809.1. Oh, 809.1. Okay. Oh, 2277, sorry. And then we're just going to divide that straight up by 238.638. So again, this is why we, again, this would be like one of those examples where, again, we don't know what we have to multiply by to get what we want. So hence why doing it this algebraic way, slightly a bit better. Okay, anybody give me an answer here for X? What do we get here for X? $95, $45. Okay, $95, $45, $04. Okay. I'm just going to go 2 decimal places. So, yep, both are absolutely correct. All right. Again, we're just talking about cents here. So, they pay like a little bit extra. That's fine. So, no big deal. All right. Easy peasy. All right. Good stuff. Okay. Any questions about that? Hopefully that wasn't too bad. No. Okay. All right. Next, let's go ahead and take a look here at our last section here for the day. Okay, which is talking about special applications of ratios and proportions. So let's talk about that. Okay. So there are two types. Let's talk about proportions here, because that's pretty much what we've been working with in a lot of these examples here. Now, what we are working with here is we can work with two types of proportions here. All right, so we're working with two types of proportions here in this particular chapter. The first type of proportion that we work with is what's called a direct proportion. Now, what does a direct proportion mean? It means basically this. It means that, okay, if we increase a value here, then the result here after the proportion is applied, it will also increase the subsequent value. So if it's like saying if I have, again, the 25 feet of rod and I make like 9 pins from that 25 feet of rod, if I increase that size of that rod to like 30 feet, then I should be able to make more pins. Okay, so that's what an increase to an increase would mean. Again, the same thing for decrease. If I decrease that amount, then my result will be decreased as well. Okay, so that is what our direct proportion means. All right. Now, the other type of proportion that we're going to encounter here in this section is going to be an inverse proportion. So an inverse proportion works exactly the opposite. If we increase a particular value, okay, so if we increase a particular value, then the result will decrease instead. Okay, so we increase something, but then it decreases back down. So then there are lots of cases where that certainly happens. We'll take a look at those. And of course, if we decrease something, then we increase that certain something instead. Okay, not hard. All right. Now, albeit the concept here isn't too hard, again, you just have to be very careful about how you set up the problem here. Okay, because direct proportions here are pretty much what we've already talked about in the first part, but I want to set this up slightly a bit differently, just slightly a bit differently. So um, we'll talk about that here momentarily. I just want to me okay, right. So I want to show off the difference between a direct proportion and a inverse proportion here. So I'm going to go to a particular couple of questions here so it makes it a bit easier to understand. Okay, so let's take a good look here at, say, let's look at a simple example here. So a simple example here would be, say, letter D here. Okay, so it says you have similar figures. You have this L shape here and you have this small little L shape here. All right, seems fair. And they want you to figure out that missing side here, which happens to be A. Also seems fair. Okay, now, having said that, what we want to do here specifically is we want to go ahead and see here, we have, again, some blank here for A. We got 36 meters for B. We got 12 centimeters for C and 14 centimeters for D. Okay, so I'm going to set it up this way. And this is a good example here of a direct proportion. So this is problem 2 or 3, 2. Okay, problem 2 using a direct proportion. Okay, so let me put this up here. Okay. All right, perfecto. Okay, so what we're going to have here is we're going to have two fractions here. So we're going to have one fraction equal to another fraction, just like we had from before. Now what I'm going to have here up top is I'm going to have the x meters here that we had from before. Okay, so I'm going to label this here. Actually, it's important that I label this. And then on the bottom here, because that's B, according to our figure, then we're going to have 36 meters for B here. Okay, so 36 meters, so I'm going to put 36 meters here. Now, the next part here is going to be our 12 centimeters that we have here, according to our problem. Let's go back. Again, we have 12 centimeters, 14 centimeters for C and D. All right. And then on the bottom here, we have 14 centimeters. Again, go back here, 14 centimeters. Now, you're probably saying, well, you've gone through this painstaking process, and you're like, well, what's the difference between what I did from before and what I'm doing now? Well, I want you to take a look here specifically, okay? In this particular proportion that you see here, you notice that the units here are on the same side of the equation for both sides. So centimeters is on the right-hand side, and meters here is on the left-hand side. This will prove to be very important to help out with inverse proportions especially. So basically, the trick is for this one here, okay, in comparison to what we did in the last section, is that we put all the units on one side of the equation. So we put the same units on the right side, put the same units on the left side. So So how do you know this is direct? Well, again, you have x meters here is equal to 12. So top goes to the top. 36 meters somehow associates with 14 centimeters. So 36 is directly related to 14 centimeters. Some amount of meters related to 12. Some amount of meters, again, 36 is related to 14. The process is exactly the same. Cross multiply and do all that stuff. That stuff is exactly the same. It's just that first part there that happens to be rather important, is just making sure centimeters is on one side and got meters on the other side. All right, so here I got 14x at cross multiply equals 36 times 12. All right. So we get 14x here is equal to 36 times 12. All right, so we get 432. And we're just going to divide by 14 on both sides. And so we get 432 divided by 14. Okay, so here we get, let's see, 30.86. Okay, so 30.86 meters would be your final answer for that. Okay. Okay, so that is a direct proportion there. Let's talk about an inverse proportion. And you're like saying, well, where is that going to happen? Okay, an inverse proportion. Well, inverse proportion happens more often than you think. So let's look at the first example here. All right. Okay, so the first proportion here says, okay, let's look at number 1. So it says a line shaft rotating at 250 RPMs is connected to a grinding wheel by the pulley assembly shown in the diagram. If the grinder shaft must turn at 1200 RPMs, okay, what size pulley should be attached to the line shaft? Okay, so let's take a look at the picture here. This is rotating at 250 RPMs, and we know that this, we have this particular grinding wheel going at 1200 RPMs, again with the 5-inch pulley. We want to know what this pulley is going to be, at least the diameter of that pulley. Okay, so this is a classic example of an inverse proportion. Now, why is that? Well, think about it this way, right? if you have a smaller pulley, like 5 inches, and you're trying to figure out how many RPMs that is actually going around, wouldn't it make sense that it goes around faster because it has a smaller radius? So if I have a big pulley, it's going to take a longer time to go around in one circle. Okay, if I have a smaller pulley, it takes much less time to go around in one circle, make 1 revolution per minute. So if it's a bigger pulley, it's going to take a longer time to go around, so it has less RPMs. So the bigger the pulley, an increase, the smaller the RPMs, decrease. The smaller the pulley, decrease. Okay, so the smaller the pulley decrease, the bigger the pulley, the bigger the RPMs increase. Whee! Okay, so let me reiterate that one more time. So again, the smaller the pulley, faster the RPMs, the more RPMs. The bigger the pulley, the less RPMs. So an inverse relationship there. So the question is, how do we set this up? Okay. Okay. So I'll show you how this kind of works. So here in this case, let's go ahead and set up this particular problem. Okay. So here we have a 5-inch pulley, and it should have more RPMs. So I'm going to put 5 inches here, and we'll put a X amount of inches down here. Now, because it's inverse, we're going to flip these two numbers around. Okay, so normally 5 inches would go with, say, the 1200 RPMs, but since it's not a direct relationship, yes, that is correct. So we'll have 1200 RPMs here, and we'll have 250 down here. So this is what it means to have an inverse relationship here. That's correct. Then we'll just do the process here, at least in this case. So again, we'll cross multiply here. So 1200x equals 5 times 250. All right, so we got 1200x equals 1250. So we divide by the 1200 here on both sides. All right, anybody got an answer for me here? $1.04? Okay, perfect. Nice. All right, good stuff. Oh, wait, hang on a second. 5 inches go to 12. Oh, whoops, hang on a second. Whoa, wait. I just realized. Okay, hang on. Whoa, wait. Hang on a second. Don't copy that down. All right, I got that backwards. Okay, that's my fault. I'm doing an inverse relationship, so even I get confused. All right, so this. All right, this is my fault here. My bad. I'm an idiot. All right, I'm gonna try this again. All right, so this should be 5 inches is equal to x. 5 inches. This should equal 250 RPMs over 1200. Yeah, that's what it should be. Like that makes. There we go. That's a lot better. All right. So it should look like this. Yes. That's my fault. I put the 250 and the 1200 in the wrong spots there. So my bad on that one. It should be this way that you see here on the screen. 5 inches equals 250 and x equals 1200. Okay. So then having said that, we have again 5 at 250. So then we go ahead and cross multiply here. Now it'll make a whole lot more sense. So we have 250x equals 5 times 1200. So we got 250x equals 6,000 divided by 250. And yeah, then I'm going to agree here. X is 24. And again, this is strictly because this is an inverse relationship. So disregard what I wrote from before and you can read this one. So that one's my bad. That's on me. So first determine what type of relationship you have, and then you can go ahead and do the rest. Okay, any questions about that? No? Okay. Okay, let's go ahead and take a look here at the next one. Okay, let's look at which one I want to do here specifically. Okay, let's look at 13. So that's on the next page. Let's do that. Okay, 13. If 12 assemblers can complete a certain job in 4 hours, how long will it take the same job if the number of assemblers is cut back to 8? Okay, now let's answer the first thing here. All right, let's answer the first thing. Is this a direct or inverse proportion? Is this an inverse? Is this a direct or inverse proportion? So we have 12 assemblers take 4 hours. We cut the number of assemblers to 8. So let's answer that question. Direct. So here's what we'll say here. We'll say, okay, 12 assemblers take 4 hours to do the job. If I lower the amount of assemblers, does it take a less amount of time to do the job? No, right? If you cut the number of people to do that same job, it's going to take you more time to do that same job, right? So a decrease of the amount of people leads to an increase in the amount of time that it takes to do that particular task. So in that regard, that's why in this case, it's an inverse proportion here. Yeah. So I just want to kind of guide you through the reasoning behind why I'm using an inverse as opposed to a direct in this problem here. So let's do it out, shall we? Let's met this duder out. Okay, so 12 assemblers. So let's go ahead and do a inverse. Okay. So what we're going to have here is we're going to have, again, 12 assemblers. And then we'll put that over 8 assemblers. We'll have that on one side. Again, we know this is an inverse relationship. We know that the 12 assemblers take 4 hours to complete this job. So we're going to put the 4 hours here on the bottom, okay, since it's inverse. And we'll put the X amount of hours here on the top to determine, what that relationship is going to be. Cross multiply here. 8x equals 12 times 4. So you have 8x equals 48. I divide it by 8. X equals 6. Okay, so 6 hours here. All right, good. Not too bad. Pretty straightforward. All right, any questions about that? Nope. Okay. Okay, let's look at 23 then. 23 should be the easiest one. Okay, life skills. If you are paid $238.74 for 21 and a half hours of work, what amount should you be paid for 34 hours of work at this same rate of pay? So the question for this one is, all right, is this a direct or an inverse relationship? Is number 23 direct or inverse? Yeah, that's definitely direct. Okay, again, you can tell here because if you work more hours, you should get paid more to do it, right? So working more equals getting paid more. So we have, again, let's do our direct relationship here. So we have 21 and a half hours here. So we have 21.5 hours here. And we got 34 on the bottom. And that equals, again, 238.74 since it's direct. And we'll put the X amount of money here on the bottom. Okay, we'll cross multiply here. Should be 21.5. So 21.5x equals 238.74 times 34. So let's go ahead and do this. So we get 8117.16 divided by 21.5. And then we go ahead and see what we get here. So here we're going to get 377.54. Okay. And there we go. Just did a little bit of algebra there, and we got it. Nice. All right. Any questions about that? Okay. Hopefully that isn't too bad. Okay. All right, good. All right. Any questions about today's 3 sections? That's the end of section 4 too. Next time we're going to go over the rest of chapter 4 here. So, and then on Friday we'll work our way into chapter 5. So again, the makeup class will be Friday at 10 o'clock. All right, just to let you know. No more questions? All right. Very good. All right. If you're keeping up with the homework, great. Okay. Continue to do the homework there. The homework is all online, due at the end of the semester. But again, the homework there would be up to section 4.2 if you're keeping up with that. All right. Well, it should be pretty straightforward from here on out. All right. By the way, once we're done with chapter 5, that's when we'll discuss doing the first exam there. So, yes, you can actually access it here on Twitch. And I have to still upload it to YouTube for some reason. But Twitch keeps the replays here for 14 days after the initial broadcast. So it should still be here on Twitch at the very least for up for another week. I plan to archive it over to YouTube so that way you have a chance to maybe watch it much, much later. So you should definitely have it available here from last Monday for sure. All right, great. Wednesday we had no class. Yes, that's correct. Because of no internet connection at all. My internet was down for like 2.5 hours or so. So there's no way I could make class with no internet connection. The only internet connection I had was through my cell phone, so it was like, well, that kind of sucks. All right. Any other questions you guys got? Nope. Okay. Nah, you're not too behind. Trust me. It's very hard to get behind in this class unless you decide not to do anything. So, all right, great. All right, everybody. I want to thank everybody for coming out to the stream here once again today. Sorry for the quality of the stream. One of these days, I'll get this fixed. All right. In any case, though, thanks for being patient with me. Thank you so much. I want to thank everybody from the couple of guys from the hashtag family coming out here today as well. Um, uh, so thank you guys very much. All right, and I will see you on Wednesday. All right, have yourself a wonderful morning and afternoon and evening. All right, and we'll see you in a couple days. All right, have a great one, everybody. Take care of yourselves, and we'll see you later. All right. Bye.